We've got a parallelogram. We're given its area, correct 2, and its shortest side, correct 2, and its longest side, correct 2. So this is going to be a bounds problem. And what we've got to do is find the largest possible size of the two acute angles in the parallelogram. Again, just so that you can visualize the problem, here is a parallelogram. Here's the longest side, shortest side, h, the height difference between the two longest sides, and the angle A, which is our acute angle in the parallelogram. Given that this is a bounds problem, I think we first of all got to set up a table and work out what are the upper and lower bounds of our various measurements that we've been given. So I've set up a table, the value we're interested in, and 2 columns for the lower bound and the upper bound. Now, 15 is correct to the nearest integer. So the next one up will be 16. And therefore the dividing line that will send us either up to 16 or back down to 15 is 15.5. And the lower bound, the next value down being 14, this will be 14.5. S is correct to 2 significant figures. So the next one up will be 4.6. So our upper bound will be 4.55. The next one down, 4.4. The lower bound, 4.45. 7.1, again correct to 2 significant figures. The next one up, 7.2. So this will be 7.15. And the next one down is 7.0, so this will be 7.05. So we've now got to decide which one of these values to choose to give us the largest value of the angle A. Well, I think you can see that fairly obviously we must choose the upper bound of the area because a bigger area will give us a bigger angle A. Now this is quite subtle. You can prove it with maths by using the sine sandwich rule and finding a minimum, but I think you can do it by logic as well. And the reasoning is this. Assume the area is fixed. If I go for a shorter L, clearly my area has gone down. And to compensate for that shorter length, I'd have to increase the separation between them, and therefore the angle A would go up. So I need the lower bound of the longest side, and the same argument is true for the S side. So I'm going to need the lower bound of S as well. So it's the upper bound of the area and the lower bounds of the 2 other sides. So redrawing our parallelogram and putting our results on. So area, which is given by 7.05 multiplied by h. And that is equal to 15.5. So therefore h is equal to 15.5 divided by 7.05, which is equal to 2.198. So looking at the blue triangle, angle A is here, the opposite is h, and the hypotenuse 4.45. So the relationship sine A is equal to h, which is our 2.198, divided by 4.45. And if you look that up on a calculator, A turns out to be 29.6080. And what do they want it to? The 3 decimal places. So this is approximately now 29.608. And that is to 3dp. And that's the answer.